Hi class, I'm here. My kids are just busy doing their own schoolwork, so I had to push the button myself. Okay, welcome to our next lesson of Algebra 1. We are continuing in Chapter 7, and we're in Section 2 today with scientific notation. In your books, you should be on page 420 to follow along, and either have the note handouts from yesterday, continuing along, or paper and pencil. So today we're going to be talking about scientific notation. You have all seen this before. You've all dealt with this before. This is not new, and we actually aren't going to go too deep into this. More of a review lesson. Now, scientific notation is something that is really helpful in different fields of science and math where you deal with extremely large numbers or extremely small numbers. It helps write them easier and also helps do math and figure problems with those huge or very small numbers a lot more easily. But today we're just going to get comfortable with recognizing scientific notation and going back and forth between scientific notation and standard notation. That's as deep as we're going to go today. So this lesson is going to be considerably shorter than the one we did for 7-1. So let's review what scientific notation is. Scientific notation is when we have a number being multiplied by a power of 10. This is the basic format for it. But what we need to know or recognize is that that digit or that number, can be a decimal, obviously, has to be greater than or equal to 1 or less than 10. So it's somewhere in this range of 1 to 10. Two examples that we see right here. 8.3 times 10 to the 5th. We know that when we multiply by a power of 10, we've studied mental math with this for years. We move the decimal that many places as there are zeros. So if we have 8.3 times 10 to the 5th power, this means we're going to multiply it by 10 to the 5th, or we're going to move our decimal place 5 places to the right, which means when I have a positive exponent for 10, I'm dealing with a large number. Then the second example, 7.1 times 10 to the negative 5th. We learned in our last lesson that when we have a negative exponent, it kicks that to the basement or the denominator, meaning division. So when we divide by a power of 10, we move our decimal point that many places to the left. So in this case, with negative 5, I know I would move that decimal 5 places to the left. So when I have a negative exponent, I need to think through the fact that I have a really small number. Okay, basic understanding of scientific notation. Again, this is review. So our next set of problems, in problem 1, is just recognizing whether something is in correct scientific notation. Not incorrect scientific notation, but in, pause, correct scientific notation. So I'm going to bring up my next whiteboard, and you're going to look at problem 1, either in the book or in the notes. And there are 3 numbers written for you. And this first step is just saying, is this actually in correct scientific notation form? Is it right? So my first example here, 0.23 times 10 to the negative 3rd. Well, I can see that I'm multiplying by a power of 10, so that looks about right. But the problem comes in right here. This number does not fall into that range of between 1 and 10. This is smaller than 1. So my answer for this first one, this is not in scientific notation. If I wanted it to be correct, I would have to have this first digit. Oops, I went that the wrong way. It would have to have that number in the front be between 1 and 10. So if I move the decimal place to between the 2 and 3, now it follows the rule. But as it is here, no. The answer is no, it is not in scientific notation. My second example, 2.3 times 10 to the 7th. Well, again, I recognize that I have 10 to a power, and then I need to look at this first number, and this one is in that range of between 1 and 10. So my answer for the second is yes. That is correct. The last one, right here at the bottom of my board and in your notes and in the book under problem 1, 9.3 times 100 to the 9th. Well, if I look at this first number, it falls in that range, that acceptable range of between 1 and 10. So I know that's correct. I have an exponent, but notice I don't have 10. I have 100. My format for scientific notation is being multiplied by a power of 10. So this one is a no. Okay, that's step 1, problem 1. What I want you to do is pause the video and try the 3 practice problems on your own. You're answering the same question. Are these written in scientific notation? Yes or no? And you should be able to explain your answer. I'm going to clear my board and write those 3 on here. You pause the video and you do them on your own. Okay, let me write these 3 problems here and we'll discuss yes or no. Those are the same ones we just did. Let's get the right ones. These are problems that take longer for me to write them on the whiteboard than it takes for you to do them. Okay, we're gonna go over this pretty quickly. These are your 3 practice problems, 1, 2, and 3, under problem 1. Yes or no answers here. Number 1, this one is a no, because this number is not between 1 and 10. We'd have to change that to make it in correct scientific notation. Number 2, it is a yes. This number is in between 1 and 10. We have a power of 10. Totally perfect, number 2. Number 3, my answer is no. Again, this number is not between 1 and 10. And this is not written as a power of 10. So that one fails on 2 points. So no, yes, no for those practice problems. Okay, moving right along. Let's go into problem 2. Problem 2 is just covering the basic skill of translating numbers from standard notation to scientific notation. And so the 2 examples that you see on problem number 2, my first one is a very large number. And my second one is a very small number. In fact, I'm going to make sure I'm getting the right number of zeros. Whew. My goodness. Okay. If you're like me, you have to maybe get your fingernail and count how many zeros you see. Okay, this is standard notation. Standard notation means it's how we would write numbers in a normal setting. But we want to translate them into scientific notation. So remember, my pattern is a times 10 to a power. My a has to be between 1 and 10, 1 being included. That means my decimal point is here right now in standard notation. But where do I want it to be? I want it to be all the way over here. Not here, because that would give me 14.3. That's greater than 10. Not here, because that would be 143. And not here, because that would be smaller than 1. I want it to be here, because that would have my first number being 1.43, which follows the rules of being between 1 and 10. So I know my first number that I'm going to actually write is 1.43. And I'm going to be multiplying that by a power of 10. My question, though, is how many places did I move that decimal? So if I was here and I'm moving it here, 1, 2, 3, 4, 5, 6, 7, 8, 9. The question is, am I going to be having my power be a -9 or a +9? Well, the best way to check yourself is, remember previously I said if I have a very large number, my exponent is positive. So that's the way that we need to remember this. And if I'm going from standard notation into scientific notation, and I have to move that decimal point to the left, that means it's a positive exponent. And that applies from standard to scientific. You might be saying, isn't she saying that backwards? Remember, I'm going from standard to scientific. Our next example is going to be from scientific to standard, and everything was reversed. So, best way to check, big number, positive exponent. Okay, so my next example though is a really, really, really small number. I see here's my decimal point, but for scientific notation, I want it here so that my number is 1. Remember, A can be, here I'm going to write that again. My range for my A, or my number, has to be between 1 and 10, but 1 is included. So if I move my decimal point here, it's 1, which is fine. So I'm going to have 1 times 10, and then I need to count how many decimal places I moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But again, I need to ask myself, is this a positive or a negative exponent? Well, if I had my decimal point here and I'm moving it right, it is a negative exponent. Or, like I said before, another way to check yourself is to know that if it was a really small number, it's definitely a negative exponent. Okay, what I want you to do is to pause the video and practice the next few of writing them in scientific notation. There are 4 given to you in standard. I want them in scientific notation. Pause the video and try those, and I'm going to clear my board and write those. As I write them, I need to make sure I have the correct number of zeros. There we go. 1, 2, 3, 4, 5, 6. Okay, if you're watching me still or again, you should have already completed the practice problems. All right. Don't mind me while I clean up my situation here. Ooh, falling apart today. Okay, here we go. In this case, number 1, I know it's a really big number. I know it's going to be a positive exponent when I'm done. Here's my decimal point. I want it here. I want it to make that number between 1 and 10. So my answer is going to be 6.78 times 10 to a positive number. Oops, 1, 2, 3, 4, 5 times 10 to the 5th. This one's a really small number, so I know it's going to be a negative exponent. My decimal point is here. I want it to be here, making this 3 times 10 to the 1, 2, 3, 4, 5, negative 5. Remember, if I'm moving my decimal to the right, it's a negative number. If I'm moving it from the right to the left, it's a positive number. Remember, we are going from standard to scientific, so these rules apply here. In fact, let me write that. Standard to scientific notation. There's my little abbreviation. If I'm moving my decimal point left, it's positive, right, it's negative. Okay, my next one. Again, a really large number. I know my exponent is going to be positive. My decimal point is here. I want it to be here, so it's going to move left. 5.14 times 10 to the 7th. Last one, a really small number. I know my exponent is going to be negative. It's going to be 7 times 10 to the negative 7th. Small number, negative exponent. Okay, what I want us to do is now switch gears and we're going to reverse the process for problem number 3. This is probably where you are more comfortable. Whenever I give you a number in scientific notation, I want you to give it to me in standard. So we went from standard to scientific notation, and these were my reminders. We're gonna switch the direction completely. So let me clear my board again and write down the 2 examples you see under problem number 3. And I'm gonna erase my little reminder here too, because like I said, we are switching directions. Now we're going scientific notation to standard. And I'm abbreviating all over the place here. Okay, our first one, 5.5 times 10 to the 6th, and 3.1 times 10 to the negative 3rd power. This is letters A and B under problem 3. I don't know why I'm fighting this battle. It was to make it so it actually stayed on the chair better, but it's not working anyways. Let's see if I can get this. Okay, we're good. Okay. Now, scientific notation to standard. Whenever I have, there's my A, or my number, and it's between 1 and 10, so we're good. This is where my decimal point is, but I'm going to move it 6 places to the right this time. So when I go from scientific notation to standard, a positive exponent moves it to the right. So I take that decimal and I go 1 and then 5 more places. Well, you'll notice you're like, wait, there's nothing else there. Well, once I move it, 1, 2, 3, 4, 5, 6, there's my decimal going to end up. What do I do with all of these empty spots? I fill in zeros. So there is my final answer. 5,500,000. My decimal point was here. I have a positive exponent. I'm going that many places to the right. That's where my decimal point ends up. And I fill in placeholder zeros. Again, positive exponent, really big number. Let's do the opposite. Now I notice I have a negative exponent. So if I have a negative exponent, I'm going to move my decimal point to the left that many places. So if this is where it was, I'm going to move it 1, 2, 3 spaces to the left. And again, those empty spots I'm going to fill with placeholder zeros. So if I were really to write my number, it's a tiny decimal number. Negative exponent moves my decimal to the left because we know that's division from what we learned in our lesson from yesterday. Really small number. Okay, pause the video. There are 4 for you to do under this problem number 3. You pause the video and attack those while I clear my board and write them on the paper, or on my whiteboard. Okay, and this is it for today's lesson. I told you today's was going to be short and sweet. Okay, here we go. Practice 1 through 4. If you're listening at this point, it means you've already done the practice problems on your own. Now we're going to go over the answers. 5.23 times 10 to the 7th. Positive exponent means I'm going to get a big number when I'm done. I'm going to move this decimal point 7 places to the right, which would give me this answer. 52,300,000. Example 2, 4.6 times 10 to the negative 5th. I see a negative exponent. That tells me, first of all, I know it's going to be a really small decimal. And it tells me the direction. I'm going to move my decimal point 5 spaces to the left. Leaving me that as my final answer. The third one, again, another negative exponent. That tells me I'm going to have a small number when I'm done, a decimal. And it tells me I'm moving my decimal point 4 spaces to the left. So there's 1 and then 3 more. So there's my answer, a really small decimal. My last one, I see a positive exponent telling me already I know it's going to be a large number. And it tells me I'm going to move my decimal point to the right 12 spaces. So I'm going to have 3, 8, and 11 zeros. Very large number. And that's what you should have for examples 1 through 4 from problem 3. Okay, for practice for this lesson, we're going to keep it to the types of problems we did today. Again, recognizing if something is in correct scientific notation form, and then being able to move back and forth between the two forms. So your suggested practice problems are going to be found on page 424 in your book, and the ones you can try are 11 through 33 odd. Remember odds because they're in the back. Once you feel comfortable with these, then you would go to Khan Academy and try the practice problems that I've assigned you on there, and they are called, nope, you'll never guess what they're called. Scientific notation. That's what you're going to see assigned to you on Khan Academy. Now remember, if you are at this point and you finish watching my introductory video, my first video on 7.1, and now this one on 7.2, you cannot receive the assigned Khan Academy practice problems without having finished day 1 tasks. So if you have gotten emails from me saying you are not complete, you need to complete that first, and then I can assign you these things. Okay. Have a great day and good luck practicing your scientific notation. And I'm gonna have to get up and stop my camera.